Now. So good morning or afternoon, and thank you for joining us today for this Solve It session webinar. My name is Marina Silva, and today we will talk about restoring asset integrity with composite repairs. Here with me is Isaac Atkinson.
Hello.
And David Blackwell will be joining us later for the Q&A session. What we would like to show you today is the versatility of composite repairs, some associated testing and case studies. First of all, let's look at the problems that metallic assets can experience. External and internal erosive forces and corrosive substances can lead to pitting and thin wall defects. Eventually, if not addressed soon enough, they are likely to go through wall. Corrosion and erosion are not the only factors, as leaks can occur due to poorly aligned flanged connections. Issues described above are mainly seen on pipework and pipelines, but we shouldn't forget storage tanks and process vessels, which can experience similar problems. And here's a photo of CUI damage on a tank. Let's look at some repair methods you may be familiar with, such as cut and weld. Apart from all the typical metallurgical issues associated with hot work, there is, of course, downtime. We also know that welding requires high level of expertise. And when methods alternative to welding are being used, there is a question of longevity. Even when we accept the repair to be temporary, we want it to last close to the lifetime of the asset and not require ongoing maintenance. And we think that composite repairs provide a viable solution to common maintenance problems. And Isaac will tell you more about it.
So up to this point in the webinar, we've covered the basics around the composite repairs and some of the problems related to these aging assets. We've also looked at areas of traditional repair methods and the issues associated with these. It is now time for us to get a closer look at what solutions Belzona can provide for these issues, mainly looking at SuperApp 2 system. So the SuperApp 2 system is a combination of a resin and reinforcement sheet, which have been strategically designed to provide structural reinforcement to weakened substrates. The resin used in SuperApp 2 is 100% solid epoxy, and therefore, as a result, Belzona SuperApp has outstanding mechanical adhesion to metallic substrates, low tendency to creep, it doesn't shrink, and the product when the product is finally cured, and also is an extremely durable solution as it does not corrode. The reinforcement sheet is a hybrid of carbon and glass fibers. By providing these two materials, we're able to have a reinforcement with high tensile strength and less stiffness, two important properties for any non-metallic composite repair system. Let's look at the three resins that we use for SuperApp 2 now. The Belzona 1981 is a fast-curing resin that is designed for cold environments. It is designed for applications within 5 to 20 degrees, and the final colour should be blue. The Belzona 1982 resin can be used for service temperatures of up to 60 degrees. Belzona 1982 resin is designed for applications in warmer climates. It is chemically enhanced, so it has a working life which is extended. Thus, it's easier to apply in warmer climates like those found in the Middle East and Brazil, for instance. Its application temperature is between 20 to 40 degrees and can be used for service temperatures up to 80. Belzona 1983 resin is a more recent addition. It's a resin that's designed for service temperatures up to 150 degrees. It can also be applied within the application window of the other two resins from 5 to 40 degrees. There are two types of repairs that you'll regularly see using composite wrap repairs, either wraps and patches. Wraps around the full circumference of repairs are typically used on piping or pipelines and pipework components in general, as long as the diameter of such components makes it easy and practical to use. However, if the pipe diameter is so great that encompassing the whole of the circumference is no longer practical, then patches should be used. So just to briefly show you the versatility of previous SuperApp 2 applications, there are some images shown here of the finished applications. As you can see, there are applications not only on straight sections, but also bends, tees, and even extremely large wraps on storage tanks. The Belzona SuperUp 2 system has been around since 2013. However, we are continuously trying to improve our products, and recently we've been undertaking further testing with the system. Previously, you may be aware that the Belzona SuperUp 2 could only be applied onto substrates that have been abrasively blasted. However, we are now happy to announce we can apply it onto manually prepared substrates compliant to the ISO and ASME standards if compliance is necessary. Although this method is not as effective as blast cleaning, it's known that hand or power tool cleaning is more practical, especially where access for blasting may be restricted. The issue then was, if the client still requires an ISO and ASME compliant repair solution, how can they, if they are unable to blast, what can they do? Which got us thinking, what can we do to accommodate the client requiring a compliant repair, whilst being unable to grip blast? We decided to enable our composite pipe wrap repair system, Belzona SuperUp 2, to also be compliant when applied onto manually prepared surfaces. So as you are aware, extensive testing has been previously done to enable the SuperUp 2 system to be compliant on grip blasted surfaces. All this specific testing would have to be conducted using the same substrate material, surface preparation, repair laminate, filler material, adhesive, application methods before the system could be classed as compliant onto manually prepared surfaces. As you can see, the surface preparation change means all these qualifying tests need to be redone. So how did we select which standard to comply with to have a consistent substrate preparation? We considered what requirements we are being asked of. These considerations involve no abrasive blasting, handheld power tools to be used, ease of application, but more importantly, measurable and also consistent. Starting from the beginning, we looked at ST2 and ST3 preparations. However, there was nothing measurable or consistent in these, just cleanliness standards. Therefore, we looked at SSPC SP11, and the reason for this was chosen is because it does require a minimum of 25 micron profile. So the compliance testing that has been carried out on two of our SuperUp 2 resins, Belzona 1981 and 1982. We have not conducted the testing using Belzona 1983 resin, as this resin is designed to be used in higher temperatures and therefore higher risk applications. Therefore, we will only recommend abrasive blasting preparation when conducting a repair using 1983 resins. Just a quick update on the compliance testing. We have completed the required compliance testing. However, we want to provide further evidence of the long-lasting performance of the SuperUp 2 system. Therefore, we have undertaken the Annex E 1000-hour test, which once completed, we are confident the results will provide further evidence of the endurance of the SuperUp 2 system over long periods of time.
Thank you, Isaac. Vigorous testing is not the only way we ensure that the solution performs well in service. We also run training courses in order to raise and maintain global application standards. From our training centers in Miami, Harrogate, and Chonburi, we train installers, supervisors, designers, and trainers. Upon achieving a trainer level, that person is then able to run installer and supervisor courses locally. And we also keep records of all people who received SuperUp training. So most countries now have validated SuperUp applicators and supervisors. There are also many designers who are able to produce SuperUp designs in accordance with ISO or ASME standards. There's also a handful of trainers who are able to deliver SuperUp training locally. So now let's put this training in action and look at some case studies from the field. In fact, Belzona maintains a substantial database of case studies on this publicly accessible website, khia.belzona.com. It's very easy to use. Is this video not working? So you just type khia.belzona.com in your browser, which opens a simple menu, and you can use keywords to search for the case study that you're looking for. So there's a large number of case studies for different Belzona products, different applications in different industries, and we are sharing all of that database publicly with our customers, contractors, distributors, and consultants. So let's choose one of the case studies. This one will be covered later in this webinar. And just to give you an example, they all follow a similar format and all give an example of how Belzona products are performing in service. In fact, a company has recently conducted a study, and they found that Belzona is actually one of the top 5 producers of B2B case studies globally. So let's look at a few examples of Super App being used to restore asset integrity. So first we go to the North Sea, where an open drain piping of a helideck required extensive repairs. 3 spirals with a total thickness of 6 millimeters were applied over 2 periods of 14 days. You can see a combination of through-wall and thin-wall defects. They were all repaired with Super App 2, and this was a fairly big application with 320 liters of resin used, almost 500 meters of reinforcement sheet, and a few kilos of Belzona 1111 to fill the pitting prior to the application of the wrap. 2 previous examples showcased offshore opportunities, so now let's look at some onshore opportunities. Here we have a carbon steel tank in Spain. It was 10 meters high, 6 meters in diameter, and it was suffering corrosion under insulation. In this case, Belzona Super App was applied as a patch over several areas. As a general rule, as long as Belzona Super App can be consolidated, patch repair can be completed. As this was a 6-meter diameter tank, the same release film used to consolidate a wrap was used for this patch. Finally, a Belzona UV stable coating was used over the patch for aesthetic purposes. In our last example, we wanted to show you something a bit different. So here at a nuclear power station's cooling water system, a pipe protruding from a concrete wall was badly corroded. Cut and weld or any externally applied repair wasn't feasible as the corrosion continued beyond the concrete wall. So what do we do when we can't repair from the outside? We work from the inside. So for this repair, a composite sleeve made from Super App 2 was manufactured and installed. It was bonded in using Belzona 1161 and coated with Belzona 1321. Let's look at how they did it. Plastic former was used to shape the Super App sleeve. This insert was consolidated. Then upon cure and former removed, it was sanded and ready for insertion. As you can see, even a brand new flange was created. A beautiful application. So these were just a few examples from the field, with more available on khia.belzona.com. So let's see the testing behind these successful applications.
Thank you, Maria. So one of the required tests is the 1,000-hour performance test. This is often referred to as a long-term test. And these test balls were designed and wrapped at Belzona Harrogate and then sent to an external test facility to be pressurized to the required test pressure and maintain this pressure for 1,000 hours. It was calculated that that without the Super App 2 repair, the spool would yield at around 600 bar, so the test pressure should be slightly above this. This image shows the test spools set up inside an explosive container due to the high pressure that the spools would see. The pressure was ramped up to the failure, where the Super App 2 repair was expected to fail. However, actually the weld caps failed and also the fittings connected to this as well, at about 800 bar pressure. No damage was actually found on the repair at all. Another example of further testing conducted with the SuperOp 2 system is the hot oil testing. Here again, we designed 4 pressure spools for a maximum pressure retention of 10 bar. We then wrapped the pressure spools in accordance with the design created before testing them at oil at around 143 degrees. Even though the wrap was only designed to withstand a maximum pressure of 10 bar, the average failure pressure was actually 44 bar, which is over 4 times what the system was designed for. Another testing that we've undertaken recently is a thermal shock testing of the SuperOp 2 system. Here we heated the system up to 100 degrees before then dunking the samples into a liquid nitrogen bath at a temperature of -60, cycling the system 5 times whilst also visualizing the samples for cracks. We are happy to announce that the thermal shock testing did not adversely affect the SuperOp 2 system. Even after providing evidence of the testing we have done with the SuperOp 2 system, we still get asked why use a Belzona SuperOp 2 repair over a standard composite wrap, which has been used in the field for years if compliance is not necessary. The video in the next slide should give you a better idea as to why. Here you can see a conventional pipe wrap being tested against Belzona SuperOp 2 repair. You can see the pressures rising on both repairs, however watch how the conventional wrap fails compared to the SuperOp 2 system. It clearly shows the conventional wrap failing cohesively, sending a projectile along with it. However, the Belzona SuperOp 2 system failed adhesively along the bond line, allowing a slow depressurization of the system. Belzona SuperOp 2 provides an alternative, cost-effective and long-lasting option compared to conventional alternatives. The Belzona SuperOp 2 system has many application benefits, ensuring an easy and safe application, plus many in-service performance benefits, for example outstanding mechanical properties and chemical resistance. Finally, at Belzona, we were able to also offer our support throughout. We even offer our supply and fix application service, Belzona Technosol, to apply and supervise a SuperOp 2 application if necessary. Alternatively, as Mourinho said, we can actually offer validated training to clients who wish to apply the SuperOp 2 system themselves.
Thank you very much, Isaac, and thank you everyone for listening. We now will take any questions you may have, and David Blackwell, our engineering director and NACE Level 3 inspector and CIP instructor, is joining us for this Q&A session. Would you like to take a seat here in the middle, Dave?
No, I'll stand up.
You do not get to stand up.
Good job, it's only a practice. You're not online,
I am online. Julia and Alice are listening to us.
Oh.
And we're sending this recording to everyone, including yourself, for comments and feedback.
Indeed.
I made changes to the presentation, but that wasn't the one I made changes to.
No, me neither.
That's why I got really confused.
I think the weird one was loaded. Okay, well we'll have the right one at the end. You need to come closer though. Let's practice actually sitting together.